Hey, good morning, Eric. So uh, let's give it a few more minutes for some more folks to join.
Okay.
Hey, good morning, Diane. Right, so I think we got some folks on the line. Eric, sounds like you have two meetings or two.
Yeah, I was just wanted to make sure that I can present and have a backup just in case.
Perfect.
Yeah, so
Yeah,
I would share from one and then I would do the audio and the video from, yeah.
awesome. Yeah, so yeah, thank you for joining. Excited to hear about Yuki,
Yeah,
container runtime and written Rust.
yeah.
So yeah, just take it away. Yeah.
All right, let's see if this, hopefully everything works. All right, perfect. Okay, let's present. Oops, no, oops, getting ahead of myself. All right, shall we start?
Yep. Yep.
All right. So yeah, so today we are here to talk about Yuki, a container runtime written in Rust. And so first, what is Yuki? So Yuki is a fully OCI compliant container runtime in the Rust, written in Rust, and it's developed currently under the containers organization, the same one that's developing Podman. So as of today, we have around 2.4 thousand stars on the GitHub. Toro, who's also in the meeting, he's actually the creator. And my name is Eric, and I'm one of the collaborators / maintainers for the project. So, and the name of Yuki really comes from Japanese, the same meaning as container, the Japanese word. So, so this diagram sort of describes what Yuki does internally, and we found that it's a very easy to read diagram to illustrate on the high level what we do. So internally, we create sort of three processes to launch the containers, and one is the main process when you call the CLI. And we create two additional processes. One, we call it the intermediate process, and then the next one we call it the init process, which will be the process that actually execute the container payload. So the reason we need two processes is because we need to, for rootless container, we would need to enter user namespace first. And then for pin namespace, we need to actually fork twice to enter into the correct pin namespace. And this sort of does, and then the rest of the process will just be setting up the process with C groups and the rootfs and second profiles and all the goodies that a OCI container runtime is supposed to do.
A question about that. So so you have three processes. So I think, as far as I understand, the behavior with RunC is just a single process.
Actually, RunC internally has a number of processes. It does the same mechanism as well. It first calls itself with RunC init to create a process, and then later it would actually call a package written in C called nsenter that it actually forks a number of times. It sort of has to do the same mechanism to enter into the correct namespaces. So actually internally, I think RunC does either three processes as well, or it does one more.
Got it. So it's very similar. Okay.
Yeah, so the mechanism is very similar, and sort of requirements come from the requirement for from using namespaces. Yeah.
Got it. Thanks.
Yeah. So so we didn't. I think the audiences, since this is the runtime committee, we wanted to probably talk more about why we chose Rust as to write the container runtime. So first is actually the implementation simplicity that we were able to achieve. So Go, because it's a higher level language with its own multi-threaded runtime, it doesn't actually, it hides some control from the user about how they can control the processes. For example, Go and RunC does not have a way to fork a process. So internally, what it does is it uses a number of hacks, and one of them was to invoking itself to create a new process, and then are able to execute the Go code. When you're using Rust and Yuki, we can just directly call fork or clone whenever it's appropriate, and we can control exactly how the process is created, how the process are set up, and how the process are entering into the namespaces. We don't really have to do any of the hacks. And this is actually my personal inspiration to write a new container runtime in Rust. When I first time was reading RunC code, I saw the difficulties of that the original implementer had to work around to achieve this. And the other limitation is Go and RunC cannot really use set namespace to enter the user namespace, for example, because Go program again has a multi-threaded runtime before any Go code was executed. So what RunC had to do was implement their core logic of how to manipulate these processes and enter into namespaces in C in a package called nsenter in the RunC code base. And in Rust, we are able to achieve this with a very simple and pure Rust implementation. And this is a great thanks to the libc and the nix crate or the libraries. They provided us with a very nice and safe wrapper for all the syscalls. So we are able to do this in pure Rust. The other benefit we notice it will be around performance. This is a very simple experiment demonstrating how performant Yuki currently is. For example, if we try to limit the runtime memory to 1 megabyte, RunC would fail, whereas Yuki would work. So in a limited memory environment, this can become crucial, and this can enable some interesting use cases where, for example, in the edge, where the hardware is really not strong and have limited memory. So a runtime like this can potentially enable many other interesting use cases. Because Rust is supposed to offer similar performance as C and C++, we are expecting the Yuki to eventually have a similar performance for an implementation like C-Run, for example. Currently, we are already showing about 30% performance improvements to RunC, but this was before we haven't started really digging into the performance optimization yet, but we are hoping to achieve more as we optimize for performance. Rust definitely has that capability and potential to reach the same level of performance as a C and C++ implementation. Oh, and one more thing. So I think currently most of the container use cases for startup and deletion time for RunC is rather reasonable. But in the future, as serverless or functional as a service, or just in general, fast scale up and scale down, it will benefit from a faster startup and deletion time, even though it may not be needed at the moment. The other thing, the other benefit that we see is there's a lot of people who in the Rust communities are familiar with system programmings, and many loves this level of abstractions. So Rust is really suitable for doing this, and a lot of people in the community are really interested. We actually had many people who join Yuki or contribute to Yuki just want to know more about container ecosystem, and a lot of them have backgrounds in Linux kernels and system programming in general, but they want to learn more about container. So that's why we think from a community perspective, this also is a very good fit. So, and in addition to that, Rust has some unique benefits from its languages, right? The first, I think the most talked about feature for Rust is its memory safety through their borrow checker. So in short, Rust have the mechanism to allow ownership of memory and move and borrow. Basically, you can dedicate the ownership of memory or move the ownership to another process or thread, or you can actually borrow the memory. So in this whole process, and make sure that there is no memory leak, there is no double free or any of the common memory safety issue, and it's doing that at compile time instead of runtime. So this is a very strong guarantee. And Rust also have a just static strong typing, so it offers that type safety. So we believe that this is actually very important for system programming in general, and this is what Rust was created to do. Compared to C and C++, Rust also has benefit that it has a very good tool chains. Cargo, for example, is it's more than that, but at minimum, it works as a package management just out of box. And Rust in general has both the high-level functional programming techniques and the low-level control over the system resource. And Rust has as much control over system resource as C and C++. So it really allows you to control using the syscalls and manipulate the process the way that it's intended to be. Rust also have a very good and fast FFI. So this would makes it very easy to integrate with something like libseccoms and libsystemd, which is something that runtime would have to support. At the same time, Rust, when implementing container runtime in Rust, also has its own set of difficulties. One of the biggest difficulty we found was that there are limited libraries and assets compared to the libraries that are written in Go related to this container runtime. For example, when we were implementing Yuki, there was no a Rust implementation of the OCI spec, parser, and serializer. The container image, the equivalent of the container image repo doesn't exist. It's used to manipulate OCI images. And also the runtime, there's no really integration test or validation test that trying to validate the OCI spec. There's for Go, there's a runtime tools repo. So, and that's something that Yuki and us decided that we can help with. We actually spent out some libraries that we implemented. One of them was this OCI spec RS. It's a pure Rust implementation of the OCI spec. So both runtime and the image spec are written in Rust with this. We are also in the progress of spin out our C group implementation as well. So eventually, we also want to build some common integration tests and other tools for the broader container runtime community. We just started building our own integration test and the OCI validation test in pure Rust. So this is something we're looking to contribute to the community as well. So there's also not many people who we found that can understand both Rust and the container ecosystem. And we found out that Yuki is essentially a gateway drug for a lot of the Rust people trying to get into the container ecosystem. So we are knowledgeable now to read the RunC code and understand a lot of the history and in the RunC implementation. And hopefully the container community can also use Yuki to learn Rust. Recently, I've seen a trend of people in the container community wanting to learn about Rust, and some of them was having difficulties to find some practical examples or use cases for Rust as they're learning it, and we think that Yuki can be a great fit for that as well. So in the future, so one of the first things that we're trying to do is we want to release Yuki 1.0. We currently passed all the OCI validation tests, except for a number of them that also failed for RunC. So we are in a pretty good shape and very close to release Yuki in our first release. So in the future, as I mentioned before, we're also looking to contribute more to the container communities with testing tools and other libraries that we potentially provide. We are also thinking to use some of the unique features that are more update. For example, IO urine was recently introduced into the Linux kernel, and we are exploring to see if we can use that to speed up some of our sys calls and other IO calls. Maybe there are other features like WASM or kernel modules. We don't know yet, but we are definitely actively exploring opportunities to bring this more bleeding edge features into the container runtime. And the most importantly, we think we're really having fun developing this. I think Toro started this project just because he wanted to learn more about container runtime. And this has been a great journey for us as well. So we just want to give credit to all the people who have helped contributing. We actually have a lot of people just drop in and decided to contribute. And that's actually a very nice community that we have. So again, we welcome you guys to join us. You can find our Discord on our GitHub page, or you can reach out to Toro on Twitter as well. So yeah, and let's see if there's any questions.
Yeah, this is great. Do you think you would benefit from creating something like a working group under a foundation like the CNCF to tackle some of these problems, or to maybe get more contributors or get more community exposure? I know you already have quite a bit, but you know, what are your thoughts on that?
I think absolutely. I think all of us started this journey, and we are not expert in actually container runtime. I think we would benefit greatly from a more senior people or senior input sort of help us guiding this journey, because as we're getting more and more mature, I think this would be something that we would benefit greatly from CNCF.
Yeah, sounds great. Yeah, just we can sync up offline and we can talk about maybe how we can, how the CNCF can help. Great. So there's a question from Eric. Eric, thanks for joining. Did you want to ask a question, or?
I was just curious. You know, I'm still learning with respect to Yuki, and I know that you know, I had had conversations with Manasugi, who is working on RunK, and you know, as you look at my particular interest is as you look at different crates to see where there can be collaboration and reuse and everything else, because the more reuse, the more stable and performant and everything else the crates will be. Are you familiar with the RunK?
Is that one trying to use the VM or like a unikernel like? Yeah, I've came across that repo before, but I didn't look into that. Yeah.
I see Toro. Okay. Yeah.
Okay. Yeah.
Cool.
Yeah.
Yeah. Yeah. It seems like great work. On the Kata containers project, what ends up happening is there's an agent, which is a lot like RunC running inside the guest that is Rust based. So yeah, Toro, it is. Yeah.
So it's sort of in general, we also sort of in a more broader sense, we also believe that Rust can contribute to even not just as the runtime level. I think there is already a project called ContainerRS under the same organization that's trying to do the CRI level. And I know Microsoft has a Crosslet that has done some of the work. I mean, it was doing it for WASM, but it has done some groundwork for implementing a kubelet in Rust, right? So there's works happening up and down, and we think that in the broader community, the Rust can also be beneficial.
Yeah, for us, there's a security thing, but there's also a pretty significant footprint. So when you look at runtime itself, there's one instance running per container or per pod. It becomes more and more relevant. So
yeah. And at some point, this is my personal opinion, at some point we're gonna have to resolve the difference between a pod and a container. Just because pod came after containers, but now everybody seems to understand the concept of pod, and a single container and pod sometimes can become a conflict. So at some point we may have to resolve that difference as well. Yeah.
Get rid of the infrastructure container, pause container, and these things.
I mean, yeah, I mean, you can see a world where you can assume pod, like container is a special case of a pod, right? And so traditionally pod is implemented with a dummy container as the holder of all the namespaces, and the rest of the container joins that namespace, right? So, but if you want to implement it again, right, you realize, oh, I can just implement a pod and make container a special case of pod, right? So as people revisit this topic, I think there will be more innovations, yeah, around that. And it's especially good when we already have CRI and OCI defined, right? And people can work around these APIs and just to have new implementations and bring in innovation into this field. This is actually great.
Is this something that maybe you cannot, what Eric mentioned, you can work with the Kata containers community to have some commonality between what runs in the Kata containers agent and Yuki, right? So maybe it's a totally different implementation, but I don't know. There may be
Seems
some
like Toru is saying, yeah, it seems like that there's probably room for collaboration, but nothing concrete.
Yeah. I think definitely there will be more, hopefully more pieces that got spun out as libraries that can be shared across different implementations. Yeah.
Mm-hmm.
As far as I understand, the RunK, he had a more narrow focus as far as just looking at like an edge compute kind of scenario, and I didn't fully appreciate yet what the Venn diagram looks like as far as kind of why there would be, why not just adopt Yuki versus create something like RunK. But at the very least, there's a lot of shared crates. So it'd be great to collaborate on that. That makes sense.
Yeah. And in the future, one of the important thing one of the important question is, can we run multiple different types of containers on a single physical node under one kubelet or under one CRI, right? Today, I mean, last time I checked, CRI was running through like this tag system, right? But kubelet, I think you can only specify one CRI. So
I see.
So this would be a good question in the future, where maybe sometimes we can have different runtimes and all under the same umbrella, and that gets exposed all the way up to the CI API server. And so, but this is future, right?
I guess for CRI, that's one thing. Do you think that are you familiar with runtime class?
Yes.
So,
yeah.
But you wanted at CRI level instead of at the OCI level. Because you could use container D to specify Yuki, Kata, RunC, RunK, gvisor. These all could run on the same node today.
Yeah,
that already exists in a way, but
yeah.
I have another question about you mentioned WASM, and how are you planning to use WASM with Yuki? Is that something with the libraries, or some of the work that Microsoft is doing with the crosslet and integrating that with Yuki? Or
we haven't really thought concretely about that, but WASM is sort of the I mean, some people dub it as sort of the next container, almost like. So we were looking into that, and we don't know exactly how we want to collaborate. Like, we don't have a concrete idea. That's probably the short answer. I don't know if Toro has thought a little bit more into this.
Yeah, maybe he may not feel that comfortable speaking, but it's okay.
Okay.
Yeah.
Okay, that's okay. Yeah.
I was just curious. I mean, this space it's also being addressed with some of the WASM modules or of the WASM community, right? So at the edge, I mean, there's one case with running small type of workloads, or like footprint workloads at the edge using WebAssembly modules.
Yeah. At the end of the day, we really see like container-ish runtime. They are the new process, right? If Kubernetes is a new operating system for orchestrating like cloud workload, be it on the edge, be it in the cloud, right? So yeah.
Yep. Awesome. Any other questions? We have Hugh Fan, Eric, Eric Ernst. Any other questions?
No, thanks. That was good.
Thank you.
Thank you. Thank you.
Yeah.
And I'll follow up with you, Eric, on how to get involved with the working group and the CNCF, and so
okay, great.
Maybe we could get something started, right? So that, I mean, it would be super if the community, got around a common umbrella to, to tackle all these problems.
Yeah.
And I see this as more of a avoid duplication of work and standardization, which actually helps end users in the end. So anyways.
Absolutely.
All right. Thanks for joining. Have a great day.
Right. Thank you. Bye, guys.
Bye.